Good morning, good afternoon, and good evening, and welcome to our day 9, the day 9 of our our 12 days of Python Bootcamp. It's a pleasure to have you here this evening also. Today we continue our discussion on Rasterio, and so you can see that I opened VS Code straight away. And so let us get to the business of the day. Thank you. Okay, so yesterday we ended at how to make a stack or a composite. Let me go to full screen. How to make a stack or a composite. So let's see how we will be doing that today. And I'm using a different data set for today. You don't have to. You can use any data set because it actually works with whichever data sets that you have. As long as it is a raster 1 and number 2, it is supported by the GDAL. So there are specific drivers of raster that the GDAL supports. And so once your raster is supported by the GDAL, Rasterio can handle it. And so this is my day 9 folder. I have a file here called rasters containing bands 1 to 7. Yesterday, we tried to get to USGS Explorer to see how we can get an image. So let's see if it will, the network will favor us today. So it is even in my search. Just search for USGS Explorer like this. And then, okay, this first link that says USGS, okay, I don't know whether I clicked on it or, okay, but this is the link. That link will take you to this place, this first link. This first link here, USGS Explorer from usgs.gov. It will take you to a place like this. I'm showing you how to download your own Landsat image and follow after. If you also know how to download other ones like Sentinel or any other raster data sets, like maybe precipitation data from CHEFs, or you have your DEM from any provider. Last time I showed you how to get it from Open Topography. I just want you to get a particular raster data set to follow along. But because of the composites that we'll be doing today, that is why I am trying to get a data set that counts in bands, like the Landsat data set. So you have to create an account and then log in at the top here. If you click on login and you have an account, you'll be able to log in straight away. But if you don't have an account, you just have to create an account here. Me, I have an account and my details are auto-populated, so I can click on sign in. But if you don't have an account, you just have to scroll down and choose create an account. But I have an account, my details are populated here, so I'll click on sign in. That shouldn't take long. Now it signed me in. I know that I'm signed in because of my username up here, Tommy Barnes. And whatever your username is, it will show up here also. And how to get data. If you know where you want to get the data, you just have to put a point there. Or if you don't know, there are 3 ways to get the data. If you focus your attention to the left, you will see that it says here that you can upload a KML or a shapefile. I've not really tried this option before, but I know it will work. The one I use a lot is to use address or place. If you also know the particular path and row, these Landsat data sets are acquired in path and rows. If you know the particular path and row, you can use that one to download the data. So I'll choose address and place, and then maybe type in my lake Bosomchi. I've been using that place for tutorials. And so after that, I click on this show, and then it will fetch it for me. So it will kind of, you remember our geocoder, so it will geocode it and find a place for you. When it does it, find your place for you, don't forget to change it to address or place before doing that. Then you click on the name of the address like this. When I click on it, the map will move towards the place. And this is our Lake Bosomchin here. And so I can now continue down to select a date range. So let's say I click on this calendar icon, or you can see that the format is in the month, day, and year. So if I choose 01/01/2024, that means that I want images from the 1st of January 2024 from, that is the from. And the to, maybe I can click on this calendar and click on today. Today. Okay, it's not really working, but I have to click on the yellow one that is highlighted. That is also today. So when I click on it, you can search for a specific month, but I choose to search for all. Once you have your place, if also, like, you can delete this one here like this. Let's say I had not zoomed into Lake Bosomchin, but I already know where it is. I can find it on the map. Sorry. All I have to do is to come to the add coordinate place. Sorry, cancel. Use map. Okay, if I use the map to use the current extent, sorry, I just click in here like this to add a place mark. Sorry about that. So if you know the place, just click there to add a place mark. You can be moving your points around to the place that you deem fit. But inside this lake is fine. I think the Landsat tile is even already a very big one. So no matter how I put it in the lake, I think I should get an image that covers the whole lake. Maybe. So after that, I go to data sets, and there are quite a lot of data sets in here. In fact, there's even a DEM here that you can download. A lot of data sets, a lot of them. But the one that we are interested in, at least if you want to follow the tutorial with me using exactly the same or the same type of data sets I'm using, then you click on this one that says Landsat. And then in here, we are not really continue to do any advanced visualization, advanced analysis. So either collection 2 level 2 or collection 2 level 1, each of them should do. And there is a difference between them. I think one of them is already corrected radiometrically or so. I've forgotten that one, but one of them is already corrected. I've forgotten the specific one. But it will not matter which one you choose. And you can choose between whether Landsat 4, 5, or 7, 4 to 5, or 7, or 8 and 9. It's just for practice. For your actual analysis, you may want to do research and find out which of the two data sets that you have to use, but we are just using it for practice. So I don't think it really matters. I'll choose the Landsat 8 and 9. And when that is done, I will skip this additional criteria. I usually don't like to give strict criteria to the downloading of my data set. Sometimes if you try to adjust the cloud cover and stuff so much, you may end up not getting a lot of data sets to select from. For instance, I really want this lake. Let's say I have raster, the tile. Let's assume that the tile covers the whole of my viewport, the map viewport here. It can be that half of it, if I put the lake even at the far end, so I can say that where my cursor is now is about 90% of the image. It can be that this 90% of the image is all covered with cloud, but the place of interest, which is the lake, is not covered with cloud. So, and that place might be as neat and clear as possible. So if I put a cloud cover of, say, give me cloud cover of less than 10%, that particular image which contains the very clear picture of the lake will not even come. So I don't like to give cloud cover restrictions. If you want, you can go to the additional criteria and give those restrictions. I just want all the images to come so that I see which one that has a clear image or view of my study area. So I click on results and then have a little patience. You see that it will bring up some images here. You can click on this image icon here to show it or overlay it on the map. And then you find it. So you see that this is one of the images. Let's zoom into our lake and see. I don't think our lake will be very clear. Looking at the images we are getting at the left, most all of them are covered with clouds. But there is one that says, see, I have one out of 8 pages. So let me check the last page and see. Okay, we still similar. It looks like we still don't have something clear. See the top side. This is what I was saying. The top side here is clear, very clear. So if this side was our study area, we have a very clear image up here. So I already have an image, so I'll not go through the stress and then extend the stream. Also by looking for a clear image of the lake. If you have an image which is clear, all you have to do is to click on this download button. It looks like a drive or a disk with an arrow pointing down. You click on it like this, it will load some download options. Here, click on product options, and it will show you the details of the file you are downloading. I've zoomed in well so that you will see, but I think if I should come out a bit, I still hope that you see. You see that it contains some bands. I can see B1 here, band 2, band 3, band 4, and all of them. So you just click on this one that usually this button that contains the size of the file. When you click on it, it will download it for you. It's usually in a zip file, so extract it, and then you can select bands 1 to 7. I think those are the ones I'm using, and then you can follow along with this tutorial. Thank you. Okay, thank you. The level 2 is corrected. Yes, thank you. It's the level 2 that is corrected. So if you want one that is corrected, just use the level 2. But if you still have to use the level 1, I think there is a way also for you to correct that image. Thank you. Thank you. I did not ask for permission to put your names on air, so I still have to be on the safer side, but I thank you. Someone suggested it in the comments. So thank you, my friend, for suggesting it. Okay, so that is it, how you can get an image. Let me close this pop-up also. Okay, and come back to VS Code. Let's pick it up from where we left yesterday, where we were trying to create a particular composite. So at the top here, I'll do all the imports that I have to do. I will first import Rasterio as real. And then I will also import matplotlib. We'll be using the pyplot manager today to do some plotting. So import matplotlib.pyplots and I also import that one as PLT. I will also import numpy as NP. And then I will import OS. So let me select a kernel so that this thing will be recognized. Okay. And then the next line, let me give a markdown that says compositing. I think it should be the same as stacking because the thing we're about to do, the command we're about to use is actually stack. So let me run this first cell and have all these things imported for me. Okay. Yesterday we did it in a very, very time-consuming way. Where is it? We read these things all each on a separate line, and you see that this is not really the best way to optimize code. In fact, look at the parts here; they are all taken. So it gives the file a lot of lines of code. It still works, but there's a way we can optimize it. So today we look at the more optimized way of writing this type of code. What I want to declare first is the images directory, which I'll call the images there. And then that one will be our rasters part. So I usually like to normalize the path. What's the os dot? That is the os dot path dot norm path, which is the normalized path. What it does is it normalizes the path for that particular operating system. Let me see whether the documentation will explain it well. Okay. It didn't really explain it, but it normalizes the path for that particular operating system. And so that means that if I give you this code and you run it on your PC, you shouldn't have a problem, because irrespective of the path separation character for the different operating systems, this numpad will be able to cater for all of them. But for now, I'll just put in /rasters, signifying this folder that I have here for my rasters. Okay, as I showed you, it contains band 1 to 7. If I bring up QGIS, come to the 9 rasters, and I put one in here, you see that this is the band 1. It's a place in Ibadan, Nigeria. So today I just decided to change place a bit. So it's a place in Ibadan, Nigeria. So you can see the bands in the individual bands from Landsat 8. So those ones are there. And then what we will do today is to loop through this particular directory and get all the files in there. And Python has a very cool function to do that. We can say bands. That means all the bands in the directory equal to os.list directory. That's list there, and I pass in the particular directory, which is images there. If I print out this bands, you should see that all these ones that are here, all the TIFF files are here. We have some XML files too. Usually they contain this statistics about the particular raster. The software and the languages, they know how to use it for, but we will not worry ourselves as to what they do and what to even use them for. And so you can see that sometimes this happens, and I'm glad that this particular XML files have been created. So we have to find a way of filtering out this list such that it will only give us files that end with .tif, because Rasterio doesn't work with this XML file. And so what we will do now is to say that, okay, this one will give us a list as we have seen. But if I should put it in a list comprehension, don't worry if that is confusing, I will explain it. I can say maybe band or maybe file for file in, I paste it in the if, and then let me collapse this side. If file dot ends with, and then I end with .tif. Sorry, it should be a string in the TIF. So what this line, if it's not confusing at all, is this one is even just like regular English. We are getting every file, or look through all the files for file in. So this one will get us all this particular place I've highlighted will get us this thing. And then what the rest of the code will do is that to check for each file. That means it will do for band 2, band 4, up to band, okay. I don't know why it's not arranging them. I was expecting one to be first, but no problem. If the file name ends with .tif, that is only when it will fetch it. So if I run this code again, all our XML is gone. So now we know that we will not open a file that will throw an error. Okay, someone is saying that he or she cannot hear me. Please, can you hear me? So that we know whether it's a fault at his or her end, or it is my fault. One or two feedback from the comments, then I can continue. Please, can you hear me? Okay, so my friend, I think that should be from your end. Check whether your device is muted, because I can be heard. Thank you. Okay, so let us continue. So now we have only the files that end with .sif. I think it is safe to put the dots there also. Okay. And so what we can do is now I want to create an empty list to store all um, uh, the files that we read, all the files, or let me say files. And so I can say stack, maybe stack list. For now, it's an empty list. And then I can come down and say for band in bands, file, or we are reading the file. So you know that this is not the full part of the file. The full part of the files, each of these is rasters slash, then this name comes. But we only have this. This thing that we are looking through will only give us band 2, band 4, and the rest. So we have to find a way of merging the images directory with the image itself to get the full part. And so that will be os.path.join, and we will join images directory with the particular band. So for the first one, I don't know why it is reading it in this way. So let me see if I can call the dots sorted on it. That feature is there that can sort it for us. So let me see. Okay, no, not dots sorted. I have to call sorted and then maybe passing the bands. If I print, I just want the bands to be band 1, band 2, band 3, band 4, so that the order in which you stack it is very important, because if you don't stack it from band 1 to 7 following the correct numbering, if you are trying to make some composites, you select band 3 and instead of it to be band 3 in the mind, because band 3 was the first, you think you are selecting band 3, but you're actually selecting another band. That is why I want to sort it before. So if I now print bands, let me see if it is sorted. It is still not sorted. Or I should declare this as a variable, maybe sorted bands, and then print out sorted bands. Okay, looks like this one has been sorted. I have 1, 2, 3, 4, 5, 6, and 7. Okay, so please, this is one thing that you also should ensure that your bands are sorted. So if yours was also sorted by default, use this particular syntax to sort it. So this print was just to verify something. And so for band in this one will be sorted bands. What I want to do is to join it, and then you know how we can read and analyze our image. So open the image, and that will be with real. I imported Rasterio as real, so I'll say with real dot open, and then I'll open the particular file as src. And then in here, what I want to do is to read the band into a NumPy array and append it to the stack list. So read band into NumPy array and append to stack list. So that will be band. No, we are using band at the top there. So or let me just say raster band, something like that, because we cannot use band. Raster band equal to src.read. I always told you that passing one here so that I don't read the entire file. You read a specific band. And then here we can see stack list dot append, and then we want to append the raster band. Okay, so what this one will do is it will go through all of them, read it one by one, and append. So after this operation, we can check to see how our stack list looks like. So we can just say stack list. Okay, so we can see that it has many arrays. So probably this is the first band, this is the second band, this is that, this is that. So we can see our digital numbers in here, and that is great. So we have that band. And it's so easy to do the composite if you have your bands this way. So let's say stack all bands. I may end up using stack composite. Please forgive me. All I'm trying to do, we are putting the bands together. Not like merging, but we are putting several bands together to create a multi-band raster. So we can say stacked bands, that should be equal to np dot stack. Yesterday we used this stack. Today let's try the stack. And then we pass in the particular list, the particular arrays that we want to stack. So in this time we have all of them stored in the stack list. And because we are not using this stack, we have to now specify our own axis as 0. This axis is the parameter that specifies the index of the new axis. So for example, if axis is 0, it will be the first dimension. And if axis is 1, it will be the last dimension. What this means is that I just want to stack it from top to bottom. So just put the files in there, like stack them one layer upon the other. If you want to take it, so maybe in the, that should be the horizontal direction also. Yeah. And so when this is done, I can, now this stack bands is actually, the bands are actually stacked if you run this particular line of code. We didn't get an error, it's a green mark, so our bands are actually stacked. So let us let's just maybe create an RGB. RGB is, I think, 432 for Landsat 8. Let's check. So we can search for Landsat band configuration. And this one that says, what are the band designations for Landsat satellites? Just open that one. Okay, so the Landsat 8 and 9 operational land imager and thermal infrared sensor, that is the one that I am using. So it's 4 RGB should be 432. Okay, so that means that I should be targeting band 4, band 3, and then band 2. Okay. But this our list. This is where the Python indexing and this ones also come in. Okay, so let me just try and do that down here. So I can say that my red is stack list. And that should that be at index 5 or 4? And I think I think I did an experiment with my let me first do what is in my note here and see. And then my blue, that should be equal to stack list, and then the fourth option. And then my green, that should be equal to stack list, the third one. Okay. Because there's a band 1 in there. and I don't need it. So the 432 should now become 543. Okay. And so I can say that my RGB, that should be equal to np.dstack. Okay. And then what I stack in here is red. In the order that I wanted, so it's RGB, so red, green, and blue. Once I have this, I can plot it. So let's just say we want to plot it. In that case, we call PLT, the plotting manager, and we call the figure. We want to create a figure with a particular figure size. So we pass in a figure size. So we want to change the default canvas size that will come with the PLT. Let me choose 8 by 8, even though I think that is the default, something like that. And then if we want to plot an image, it's plt.imshow. And then in here we pass in the particular image, which is our RGB. And then we can also now say plt.show. If we did everything correct, we should see an image here. Okay, so that is the image. I think my combination might be a bit wrong. Is it not supposed to be? So the fourth item in the list will be at index 3. I think so. And then the third item should be at index 2. And then 1. Let me do that and see. I don't think so. Or maybe because I've not normalized this this RGB. So you let me undo this once. This RGB, because usually if you want to see for visualization purposes, you have to normalize your stacked raster. And yesterday we found out that we can normalize it with a function, but I'll not do that today. I'll just say RGB normalized, and that should be equal to, you open a bracket and then the RGB itself, the raster itself, minus minimum of it. So we can say np.minimum, the value of the RGB raster. So np.minimum of RGB. And then after that, we divide it by the maximum of the raster minus the minimum of the raster. So that will be np.max of RGB. And outside that one, I subtract the np.min of my RGB. So what I can do now is to plot the RGB normalized, hoping that we will see some change. Okay, now our image is brighter, but I still think I'm getting my band combinations wrong. But that is not the point of the tutorial. I know now you know that we can stack. In fact, and we can go ahead and save this. So let's see how we can save it and even visualize it in QGIS. Now we have it only existing in memory as a NumPy dataset. If we come here, you see it. RGB normalized is here. We only have it as a NumPy array, so we can save it now and then see the raster. Okay, so saving composite raster. Okay. What we can do here is we need remember when we started with rasters, you have the profile of the raster that contains some metadata like the affine transformation, the coordinate reference system, the width, the height, and all those things that make up or that allows us to plot the raster in a geospatial or spatial space. We have to get it. But this RGB normalized you see here is not a Rasterio dataset. It's a, you see, this SRC is a dataset, Rasterio dataset, and it contains all those attributes that we want. But this RGB normalized that we are coming to save does not contain any of those attributes. It's just a NumPy ND array. So we have to get the metadata from a particular data set, and then we use that metadata to save this ND array. So let's see how we can do that. Okay. And so what we can do is that we open up one raster. And so let me come here. And then if you don't have a raster to open for that purpose, that means you have to now create your own dictionary containing those stuff. So I'll copy the whole path, collapse it. And then I can say score band 1 path. Put an arrow in front of it. If you're wondering why I put an arrow in front of my path like that, we have something we call escape characters in programming. If I type, I don't know, when I'm on Linux, my keyboard configuration seems to be a bit different. But if you type \n in any programming language or most programming languages, that will take you to a new line. So if you, what should be wrong with this string? Okay, it's unterminated. So if you have, let's say, a path that, if especially for Windows and the path is a backslash instead of a forward slash, and you have something like /n, like a file name begins with n, what will happen is that when the Python gets there, it will think you want to go to a new line and it will go to a new line. But if you put an arrow in front of your path, you see that the color has even changed. It tells Python that it's a raw string. It's not a, it doesn't, even if it contains any special encoding or characters, you should treat it as a raw string, a literal string. Take it as it is and not as any particular encoding. Okay, so now we can say with real dot open, and then we open band 1. Sometimes I rely too much on IntelliSense. Band 1 path as SRC, or maybe we should change the name. SRC is becoming too much. Maybe as data set. And then we can now say the metadata, which we just used to call meta for short, is SRC dot meta. Okay. And then now we will come and save our raster. So what we can say is with real dot open, and then what is the name we want? We want to save it just where the file is located, the Python file is located. So I'll not put that in any, or maybe I should create an output folder and put that one in, maybe. So what I can do here is to say output, so that I keep this organized. Output there, short for output directory, it should just be named output. And because this one does not exist, I have to create it before I access it, because if I don't create it before accessing the path, to tell me that the path does not exist. And to do that, you just have to say os dot make this, make directories. You pass in the directories you want to make, which is now our output there. And then if the output, if it already exists and you run your code, it will not do any, if it doesn't exist like now and you run your code, you'll not get an error. So see what will happen if I run this particular line. My output folder has been created. Let me delete it and then run it again. It has been created. If I run this particular file again, I get an error, which is a file exists error. I'm trying to create a folder which already exists. So to go around that one, you just have to say exists okay equal to true. I put exist okay equal to true. If it exists, it will fail silently. If it doesn't exist, it will create it. And so now I can say with real.open, and I like to break things down like this so that maybe you understand it. And also that is how I really like to write my code. to keep things simple so that if I have to change something, I don't have to change it at multiple places. So I can say output raster, that should be equal to, we want to join this part with the file name so that we'll get something like this. So what we can say is os.path.join, and we join output there with the name which I want to call composite.tiff. Okay, so with real.open, now I can pass in this output raster. And then because I'm writing it, I put W as DST. I wanted to type dataset, but I already have dataset at the top there. And all that I have to do is to create my raster is to say dst.write. And then I write in my output data. So out, that should be output data. Where is that one? How did we name it? RGB normalized. Okay. So if we did not do anything wrong, then when we run this, we should see our file created, and we have an error. I told you in the beginning that when you get errors like this in programming, the first thing to do is to scroll down to the last line. That is where the most important message is. Integer weight and height are required. Okay, so it looks like we have done something wrong, and I can see it from here. We have to pass in the metadata, and we can spread it using this spread syntax. For dictionaries, you don't have to type in everything here one by one. Okay, I think I have to show you what I'm saying on Rasterio's own website. If I come here and say Rasterio docs, maybe the Python quick start, just search for Rasterio docs, it will take you to, you get a link to come to this place. If I come to creating data, you see that before you can create data, you have to pass in, you see with Rasterio.open, this is the part that they are creating, and write mode. And now you have to pass in all of these things one by one by one. That is too long to do it, but we have it in a dictionary here. And when we use this syntax, what will happen is that this meta, as we saw earlier, is a dictionary. So Python will find a way of spreading all those variables in there so that at the end or at runtime, it will look like this in memory. So that we save time. Okay, so that is it. So if I run it now, it should not complain that it doesn't have height. Now I see that the source shape is also inconsistent with the given indexes. Take a look at this thing. It says here that it is 468 rows, 710 columns, and 3 dimensions or 3 layers. But if we check where's our variables? A variable, where is the RGB normalized? Here, 3. And the bound 1 raster that you read, what did we name it as? Was it dataset or DST? Let me check. The one that we are copying this metadata from as dataset. So let me check the dataset. Datasets, okay, it's not really giving us its properties here. But we know for sure that we copied the metadata as meta. And this one, can we expand it? Okay, maybe we cannot. But if we are able to expand it, you see the count of the raster. But we know that this RGB normalizer we are trying to write has 3 layers. So let's see the count of our metadata here. So we can just say here that print src.count. We want to see the layers in there. See that the layer is only 1. So it is not inconsistent with 3. So what we have to do now is to update our meta dictionary so that the count there will be updated to 3. And how do we do that? What we have to do is to say meta.update, And then what do we want to update? You open another curly bracket like this, and we want to update count as 3. So this should fix that error. Let's see. Another one again, and this one says that it has recognized 3 and 3, but it's still saying that it cannot do that. Okay. Usually it happens when stacking occurs. Sometimes it is kind of a bit transposed. So we have to now transpose the data that we are writing, this RGB normalized, to fit the size, or how do I put it? So usually row, column, and layers. We have to try and then adjust it to fit it. Where is this one? RGB normalized, and the data set you are trying to write. These are the values are the same, but sometimes I don't understand why this thing happens. So when I was searching, I found out that I have to transpose the data that is coming in, the RGB normalized that is coming in, before this one in particular can be fixed. So we have to now transpose the stacked array, just one array. And so that will be, let me call it output data. You can call it anything, not output SATA, output data. And that should be equal to numpy.transpose. And then what I want to transpose is the RGB underscore normalized. Okay. And then now I have to tell it how to transpose it. So I'll pass in this tuple, which is 2, 0, and 1. This is not a constant. It depends on the number of stuff you are stacking. What I'm telling it here is that the third, which is the count, the third part of the tuple, which is the count, should now be the first. And the first, which is the row, should now be the second. And the second, which is the column, should now be the third. It's just like we are switching positions here like that. So I found out that this works. Wow, this also did not work for me. np dot transpose. Okay. Did we do something wrong again? It is saying again that it's inconsistent. I don't know why. Let me try and restart. Restarting will not be necessary. Okay, restart it and let me see. And then what I like to do when I restart is also to clear all output. So let me come up here and then run this again. Okay, run this particular cell again. And then run this one too again. And then run this cell again. Okay, so it is still showing this particular error, and I honestly don't know why it is doing so. We are writing it, we are spreading this particular part, or we are supposed to specify. No. Okay, let me specify the number of counts of the raster and see. It still did not work. Okay, let me take time here and look through this code and debug it. Because it should work. It should really work. We are opening this band 1 to get some attributes in there. With real, we are opening the band. We are copying the metadata. Here we are updating count to 3. The spelling of count is also correct. And then this place we are making a directory, which is not really the issue here. Our output raster is defined properly. And here we are calling numpy.transpose. We pass in our RGB normalized. And then we are writing it here. With real.open, our mode is right, and we are writing it as DST. And this should not throw an error at all. Or there's a problem with our normalization function. Let me go up and check. The RGB itself minus the minimum of the RGB divided by NP dot argmax. This one here, the maximum minus the minimum. This one looks correct. And then let me see. I'm stacking the bands too correctly. Let me come up here and see if I have some mistake in here. I'm opening rasters, sorted them, and this is my stack list for binding raster. I'm joining this. I open each and every one of them, read the first one, and store it in my stack list. And I stack this on the 0 access. And this is also correct. So what at all is causing this problem here? Okay. Let me check. This composite.tif is also inside there. Let me open it in QGIS and see. Zoom to layer. Okay, it's an empty file with 3 bands. I honestly don't know why this is happening, because the same code works in my notes without fail, and it doesn't work here. Let me print this shape. src.shape print. This one should be src shape, and then I'll print data set. Oh, I think I now see why. And you probably also saw it. I think I've been used to using src. Instead of, I opened this in as data set, so I was supposed to access data set dot meta and not src dot meta. Usually like that, I want to restart my kernel so that I know that all the variables in the memory of the engine is cleared off. And then what I'll choose to do is to say, let me click on the first one and choose run all. Did I delete the output folder? Okay. Even if it's in there, it will. So now we are saving our raster, and it's still giving us this problem. Wow, that is strange. So as dataset.meta, let me print dataset shape. So that should be dataset.shape. Okay. It should be maybe dataset.read. You have to read the band, then call the dot shape on it. Okay. Let me see that one. Data set, not data set. Data set.shape. So that this is 406 by 710. And the one that we are trying to write, which is the RGB normalized, where is that one? Let's just print that one to here. So print composite shape. Let's set that one to be output data dot shape. Okay, so I'm beginning to appreciate this thing here. The dataset dot shape is this. What you are reading in there is a single band raster. But I think we updated it here, so that shouldn't be a problem. Because at the end of the day, it's this method that we are passing there. So let me print the content of meta here and see. The count is updated to 3. So that should not even be the problem. Okay. That is the shape of the output data. Let me not print this. Let me print the original one to the RGB normalized and see. So I'll copy this line, paste it, normalized shape. So that will be RGB underscore normalized. Okay, I'm now beginning to appreciate the differences here. So the composite shape is this. The RGB normalized shape has been turned this way. So if that is the case, then let me try writing the okay. Output data here. And I think that is what I should have done a very long time ago. I don't even know why. Forgive me. It escaped. It escaped. But I think it has also helped you to know some of the errors you can encounter and how to deal with it. I wish I can say that this part was intentional. It was not intentional at all. I just declared the variable and forgot to use it. So in my mind, I thought like when I transpose this, I have passed it here, but I had not passed it. So I wish I can say it was intentional. I really do, but it wasn't. But you have seen that working with rasters, it is not difficult, but some of these things can really worry you. For instance, if you get one pixel, a very stubborn pixel, which will overflow just by one, that will really be challenging for you. So all I needed to do was to change it from this shape to this shape. So you have seen, as I said here, that I was just swapping their positions. So 3 to 2 and blah, blah, blah. So now when we come to QGIS, let me refresh. Now you see that I have a composite here. When I go to you can see from the left side that there's band 3, band 1, band 2, band 3. But when I also go to the properties, you should see that it has 3 bands here, band 1, band 2, and band 3. Okay, if you see the dimensions X, Y, and the bands are 3, and all the other data, the metadata that we pass in there, they are also all there. Okay, so now we have learned how to create composites and save them. The next on our list is to see how we can, let's see, now you have this, let's see what we can do. You have saved composite raster. Let's see how we can reproject a raster. And so that's one, we will need extra imports. reprojecting a raster. We need extra import. I think we have already imported NumPy as NP. We have imported Rasterio. But what we have to do is to from Rasterio dot warp, we import first what we call the calculate default transform. We also want to import the reproject and maybe the resampling. Okay. Once we have I just saw that the stream just, I don't know whether it refreshed itself or it went off for a while. Please, can you hear me? And can you hear me and also see the screen? Okay, thank you. So in order to reproject a raster, what we can do, let me leave this import here and then run it. And in the next code cell, let's say we want to reproject the composite raster. So this one, I'll read it inline. So I'll say data, or maybe let me say composite raster. That should be equal to real.open. And then I will now say it's inside /output / composite.tiff. And so I can say composite raster.crs. I want to inspect the coordinate reference system of this CRS. I have a proj error, but that is not what we are focusing on. We can see that this is in WGS84 UTM zone 31. Okay. And so we want to maybe reproject it to WGS 1984 geographic. So we can say destination, which I can say DST CRS, destination CRS. Let me set that equal to EPSG and then colon 4326. That is the EPSG code for WGS84 geographic. And then let me run that line again. And then what I need to do to reproject the raster is to first open the original image. That will be with real.open. And then what I want to open is the, if I set this thing as a path, I could have easily called it, but now I have to copy all of these things over. That's why I love using paths or variables. So, but no problem. We can still read it as src. And then here, let's print. Okay, we've already found that one. So that is in UTM zone 31 north. So there's no need to print it again to prove anything. What we have to do here is to say transform. We are getting the transformation. That is the affine transformation. We also get the width. And then it will also give us the height. All of these are being calculated by the calculate default transform. And then in here, we pass in a couple of things, and I'll explain each of them. Don't worry. So SRC, it first takes the CRS. You can see it at the top there. SRC CRS, that should be equal to SRC .crs, and then destination CRS, which is also DST CRS. We set that one to equal to also our destination CRS at the top there. So that should be also DST CRS. And then it also takes a width, which should be src.width, the height src.height, and all the rest. So width should be src.width, and then height to be src.height. But even though we also want to, we can leave it here, but you see that there are other things that we can also pass. What I want to pass in here is the bounds of the data set. Even though we don't see it here as one of that, but I found out that I have to pass it in for it to really work properly. And so I will also add the bounds and spread it in like that. So src, don't forget asterisk.bounds. Okay. Now, after to this calculate default transform, we use these parameters we have given it to calculate the transformation needed to convert the raster from one coordinate system to another. In this case, we are not just even, I think we are actually transforming it if you are going from projected to geographic. But it should work for whatever CRS that you are using it for. And then here we also, as always, whenever we are saving a raster, you need the metadata. So we can say metadata, or metadata, let me type this one in full, equal to src.meta.copy. We are copying that one. And then we have to update it. So we have to say, because the metadata for the composite that is coming in is completely different from the metadata of the output raster that will be generated. For instance, the coordinate reference system will be completely different. The transformation parameters there will be completely different. Even maybe the weight and height may not change, but the bounds, that is why I even pass it in here so that it will be also calculated well for us. The bounds of the raster will change because the bounds are just the extreme coordinates of the bounding box of the raster. And those coordinates will change once we are moving from one coordinate system to another. So we have to update a couple of stuff from this metadata. So we can say metadata.update. And what do we want to update? First is the CRS. This CRS will be given to us by the destination CRS. So it is changing from src.crs to destination CRS. Let me scroll up a bit. And then the transform, that should also change to this transform, that the new transform that will be calculated for us. So transform. And then we also update the width to this new width that will be calculated as width. And we do same for the height. Sorry. What is happening to my typing today? The height is also from the height that the function there will calculate for us. And I think these ones are the necessary ones that we have to change. And then after we have done this, we are still inside the same width block. Now we reproject the raster. Okay. So with, again, we are saving a file. So with real.open, then what name do we want to give it? Let's say output composite path, output reprojected path, reprojected. Let's set that one equal to, we already have a variable there for output directory, I think so. So we can say os.path.join, and we join outputs there. I should be correct, together with reprojected projected.tif. Okay. So with real.open output reprojected, and then this one too we are writing, and then we spread the metadata as always. So we spread the metadata maybe as DST, and then, oh sorry, this width is lowercase w, and in here, well, we are trying to reproject something that is not a single raster. And so we have to now loop over all of them and reproject it. Remember, if it is a single raster, you can just simply call the reproject, the one we imported from Rasterio up there. And then it will ask you for some things, the source, the destination, and the rest. But because this composite, in fact, if we come up here, where did we save it? It was this place. Okay. And then let's just create a code cell before the reproject, and then read this output raster. So with real.open, let me copy this one. Let's read it and count the bands. So real.open, I don't need this part. Maybe as file. And then let me print file count, which should be the number of bands in there. I see that it is 3. So I cannot just treat it as if it's 1. If it is only one band that you are reprojecting, you do it this way. You say your source may be equal to which one is that? Then your source will be equal to that particular band. Let's just say so. But if it's only one band, then I'm sure when you read it at the top here, you will access the band like maybe band equal to src.read, and then you read the first one. But you can see that I didn't even read anything at all because we are dealing with multiple bands. So in that case, that if it's only one band that you are reprojecting, you just pass it in like this and you are safe. And then other things that we have to pass in is the destination. So the destination is the raster that we are reprojecting, and that one now becomes maybe the band itself. By this time when we are saving it in a new place also, so but it can be the band itself also as the source and destination. It will know how to reproject it for you. It will not overwrite it because we are saving it in a different place. And then no, this one should be the DST rather. No, should not be the band. So in the case where it's only a single band, it should be the DST rather. Even if it's not, it's still the DST. Sorry, it should not be the band itself. The source and destination can never be the same. And then the transform, that is the SRC transform. That's place we pass our transform. And we also have to give it the SRC CRS here. So it's just that everything is source and destination. That's src.crs. And then we also have to give it the destination transformation and destination CRS. So DST transform, that should be transform. You remember our transformation at the top there. This one, sorry, SRC should be src.transform. Okay, the original transformation. And then we also have the destination CRS, that is DST CRS. That should be equal to our DST CRS that we declared up there. And then you also pass in the resampling type. So resampling. So remember we imported resampling at the top there. You can say resampling dot There are a couple of them. Okay, I think I know of the nearest. I don't know why this VS Code is not giving to us. I think there is linear also. This thing has been closed. Why is it saying it has not been closed? Oh, okay, from here. Do we have an error anywhere? So this place too is not closed. Was it the reason that this one was not popping up? So if I now say resampling dot, that we have all these resampling methods here. So it depends on which one you want. Average, bilinear, cubic, and all that. But I'll go with the nearest. And then if it is a single band, this will work. But our band is multi. Our raster file is a multi-band raster. So we cannot treat it just like we are treating a single band. So I'll cut all this code. It's still useful though, but I have to cut it. And then I'll now run a for loop. So for each, so if you are reprojecting a composite raster like I'm doing, let's say for, no, this is not JavaScript, for I in, and then now a range of, these are Python stuff. This is not specific to Rasterio. I'm going from 1 to src.count plus 1 because you know that this range function will end at n minus 1, but I want to get it to the very end of the number of bands that are in the raster. So I have to add 1 to it. And then when that happens, I can now paste my reproject inside the for loop. And then a few places that will change is, and I can now say that this SRC, it imports as SRC, yes. I have to now call Rasterio dot band. No, sorry, Rio dot band, and then passing the particular band that I'm interested in at the moment. So that is SRC, and then I. This should not look confusing. I'm creating the band here. So the source band that I'm projecting gets the source, which is the raster data set. And if you are now iterating and you start from band 1, this I will be 1, so it will be band 1 of the source raster. If it gets to 2, it will be band 2 of the source raster. If it is 3, band 3 of the source raster. And then this DST2 should be row dot band, and then it should be DST comma I. So that one too, if it gets to that point, then it's reprojected. If it gets to that point, then it's reprojected. Okay, someone is saying I should try. Is it Lankzos? I think this is a new term to me. Let me run this one and see. And then we have error again. Calculate default transform got multiple values for SRC CRS. Did you place? So which one is it? You only have one of these. Why are you saying that it's multiple? Okay. Let me look at this thing again. Or sometimes it is these arguments, these names that cause those problems. Let me delete all of them. And run it again. Okay, I have another error. And this says that it's a CRS error. So that first error has been fixed. Now we have a CRS error that says the well-known text could not be passed. OGR error code 6. So this one is coming from, I think, our destination CRS. So I don't know why this is throwing the error. There might be changes in the package. So what we can do is to maybe import proj and then use the proj to create a CRS object. I think that one should work. So I will copy this and then create it properly with proj. Destination CRS that should be equal to proj.crs. And then I pass in this CRS. Okay. So I think that should. Is this what? Import PyProj. Sorry. So this is supposed to be also PyProj. You are not using the actual proj. You are using PyProj. Okay. Now I have to run this place again. Okay, we have a green mark. That means our reprojection is done. So I'll go to QGIS. I don't even need to refresh it. It's in there. And if I go to properties and go to source, I see that the assigned coordinate reference system is WGS 844326, like I put there. If I bring the composite, go to properties and source, you see that this one is UTM zone 31. And also, of course, we can check this in Python. So let me come. And then I named it output reprojected. By the way, this is inside the width. I don't know whether it will work. And let me say output or projected equal to real.open. And let me open the output reprojected. And then let me, okay, I don't need to reproject it again. So let me bring this to a different code line, a code cell, so that I don't end up running the reprojection again. And I can say projected.crs. I don't know why I'm getting this proj error, but you see that now it's WGS84 UTM geographic. Unlike the one that we got at the top there, that was, I think we printed it somewhere and we found out that it is zone 31. So we are also done with the reprojection of raster. I think the next one on our list, that should be cropping a raster with a shapefile. The time will not permit us to do mosaicing today. So let's look at the cropping and then we'll do mosaicing and the other stuff tomorrow. So I'll come down, cropping raster with a shape file. We need some extra imports. What is wrong? Okay, I don't know why. Okay, it's not working. We need extra imports, so let's import GeoPandas as GPD. We are coming to do read a shapefile. Even though we don't have one, we will create one very soon in QGIS. And then from Rasterio .mask, not mask, mask, we want to import mask. Well, usually I find it weird to use the mask, so I usually import it with an alias of R mask. Not this one. R mask, like this. And then what we have to do now is to read a region of interest, so an ROI. Let's go into QGIS and create one shapefile quickly. We will crop the composite. So let me bring it. And then inside the day9 folder, let me create a new directory here called maybe SHPs. And then inside the SHP, I right click, go to new, and then shapefile. I will change the layer name here to ROI. And I'll leave this. Geometry type should be polygon. And check this one. The coordinate system should match the coordinate system of your raster. So just make sure that that one is also done. I don't think it should be a. I don't think I rushed through the process. It's just way easy. Go to new, right click on the 9 folder, go to new, and click on directory. It will bring this pop up. Type any name for the folder where you want to store your shape file. And then when that folder is created, right click on it, go to new, and then shapefile. You see a long name at the top here. Before you see the .shp, you see new underscore layer. That new underscore layer is what I renamed. I double click on it like this. Or you can put your cursor there and delete all of them and call it any name you like. I called it ROR. And then come to geometry type, select polygon. Make sure that this coordinate system matches the coordinate system of your raster. If it is not listed here, you can click this world icon. That will open up the coordinate reference system manager. Then you can use your EPSG code to search for your coordinate system here. If you don't know it, I've shown you how to do all these things or get a particular coordinate system on epsg.io. So now what I'll do is to drag that shapefile onto my map canvas. I have it here. It's currently empty. So what I'll do is to create the shapefile. Okay. Because of these colors, I don't know whether I'll be able to see what I'm drawing well. So I'll bring the band 1, which I know is gray. Put this shapefile on top of it. And then you right click on the shapefile and click on toggle editing. Not query builder. Toggle editing. So that will make it editable. And on your toolbars here, you should see this particular toolbar, which is a digitizing toolbar. If it is not there, I think you go to view at the menu bar and go to toolbars and make sure that the digitizing toolbar is checked. In my case, it's checked because it is there. And just after the pencil, that toggle editing is also at the top here. You count 1, 2, and you see the option that says add feature, in this case, a polygon. Click on that one. So let me just select an area inside here. So I'll just go click 1, 2, 3. I'm trying to draw a square. If you think you are done, you right click. Sorry, cancel. I was supposed to define the 4th point. So now I'm done. So what I can do is to right click. I will not give any ID here. I click OK, and the shapefile is created. Then I can click on the pencil again. It will prompt you to save edits. Then you save it. Now we have this shapefile inside our folder that we can use. Due to file integrity errors, I usually like to close the stuff that I'm not that I'm going to use in another software. So this is all that we did to get a shapefile in here. So I'll copy this shapefile's path. In your case, you will have your own shapefile of your study area. So it's all the same, just that I create one. And so I've opened this region of interest. And what I have to do now is to open up the raster that I want to clip, which is also, so that's our composite path. Let me also declare that one. It's in the inside output and then composite.tiff, copy path, and then paste it in. Okay. Now, as always, we go with rio.open, and then we open our composite path as src, and then we get the shapes, the boundary that we want to use, and all of them are defined. Those coordinates are defined. I told you when we were doing GeoPandas that there's a special column in any geodata frame. It is called the geometry column. So the shapes that make up the polygon are all stored in that geometry column, and we can access it like this. If I choose to call them shapes, I can say it's equal to the R. We have not read this thing. Sorry. I have to read the shapefile first. So we can say GDF, which is the geodata frame, equal to GPD dot read underscore file, and I want to read the ROI. Okay. So that should be, the shape should be GDF dot geometry, like that. And then when you remember when we were reprojecting, okay, that error is gone. It was a temporal one. We're reprojecting. If we are cropping to, let's say, cropped image, and then the cropped image transform, the transformation will also change. So cropped image transform, that should be equal to our mask, the one we imported at the top there. And here, what we pass in is the SRC, the data sets, the shapes, and we also have to say that crop equal to true. So not crop minus true, crop equal to true. And if we put our cursor on the mask, the other things that we can pass in, but the most important ones are the ones I've shown you. I will not say the most important ones, but others are also important. But it's the crop that I want to draw your attention to. So whether to crop the raster to the extent of the shapes, and that is what we want to do. I don't actually know why this one is false by default. I actually don't understand, because this is exactly what we want to do. We want to crop the raster to the extent of the shapes. Okay. Now that we have this line defined, remember that when we crop our raster, the size will change, the number of rows and columns will change, and so the boundaries will also change. So we cannot use the metadata of the original raster to store the cropped raster that we will create. So what we have to do is to get the metadata and modify it as always. So we can say out meta, set that one to be equal to src.meta.copy, so that we don't cut it. And then we can say out meta.update. What do we want to update? We want to update the shape, which is the rows and columns necessary, and we also want to update the transformation, because this cropping operation actually returns a new transformation for us. Okay. Let me see if I'll get a return type for you. It's a tuple. It returns a tuple. Let's see if so it returns a tuple, 2 elements. The masked array, which is the thing that is masked, and it also returns an output transform. So information for mapping the pixels to a particular coordinate system. So that is why we are accessing the 2 elements here, because that returns the arrow mask, or sorry, the mask, which I named arrow mask, returns the masked raster and the new transformation for the masked raster. So I told you that when you crop it, obviously, the number of rows and columns will be smaller than the original. So we want to update the height as this new cropped image. So the cropped image dot shape. This one is not a Rasterio data set, so we cannot call the height on it. But it's a NumPy array, so we can access the shape. Remember the shape object that we were pressing when we were getting that error. So the height and then the width. sorry, the width should be modified. And then this one should be also from the cropped image dot shape. And then we want to access the second. Okay. And then I told you that the transform also changed. So the transform form over here should be equal to cropped underscore image underscore transform. So with that, we have updated the metadata of the new file that is supposed to be created. This thing will go away very soon. It's my VS Code inspecting my code. And then inside the same width, in the same indentation, now we save the new file. So save the cropped file. And here again with real.open. And this is the place where I was supposed to create a clipped path also. os.path.join output there with a file I'll call clipped.tif. Okay. So with real.open clipped path, remember we are writing, and then we have to pass in the out method. So out method, and we are writing this as DST, usually the convention for ones that are going out. And now I can say dst.write, and what we want to write is the cropped image. This thing will throw an error, and that is because I am treating this file as if it's a single band raster. Remember when we were reprojecting, we had to do it for each and every band. And so this code here will actually work for a single band raster. So if I duplicate this, let me delete this part. I know it will throw an error. I will intentionally run it so that you understand. I come into rasters, just pick band 1, copy path, collapse this, and paste it in here so that if this one fails like I've told you it will fail, I'll show you how to do this one for composite image. So let me run it. And then yes. Hey, did I just type join wrong? I was expecting an error, but not that one. And this thing managed to work. Okay, let me see. Okay, I've commented the composite one. So the band 1 was now clipped. If we come into QGIS and refresh outputs, that is why it worked. So this clipped is here. If I turn this off, you see the clipped image there. I turn it on. So it has clipped it nicely for us. Okay, now let's see if we use the same approach that was able to clip this single band raster on a composite one. So I come down here and then I run. Did it just wait? I think I'm getting a bit confused here. What is it I'm doing? This one is now grayed out, so it's the composite that is being clipped now. And did it just work? Let me delete this one. We'll delete it in VS Code and give some proper names. Clipped. This one. Move to trash. Okay, so now I'm clipping composite. So I'll say clip composite. Let me come down here and run it. If I say that I'm not surprised that this has worked, then I'm lying. So let me bring it in. It was able to do it. While I was preparing my notes and all the analysis that I've been doing with Python, I think such a thing has been throwing an error. These things they don't cease to amaze. So it has worked. Maybe the current versions of Rasterio is able to handle that, and that is great. We can see all the 3 bands in there. Let me try it on the single band also. So I'll comment the one that is the composite, and then this one, and then clipped. I'll change this one to clipped single. When I run it, that one too has worked. Let me come. Clipped single is also there, and it has also worked. Great. But maybe at your end, you will also be experiencing the problem that I talked about. It can throw an error, actually. So in case your own throws an error, especially when you are doing the composite, let me uncomment this and comment this. In case you are doing the composite and it throws an error, in here when you are writing it, what you have to do is to say dst.write and now writing the images themselves one by one, each and every single band. That will be cropped underscore image, and then we use a selection. So we select how do you call it? That should be I -1, and then I. Sorry, no. I don't know if you're asking then why this syntax. Okay, so this means that not this is not -1, this is I -1. So this means that the Python indexing has this issue of starting from 0 and all that. So you index into this cropped image. Usually, if it is a multi-band raster, it will crop all of them one by one like that. So you index into it and select the particular band here. I know it's kind of a weird syntax, but this is what it's doing. It's just selecting it at that particular index, bringing this -1 here to take care of Python's indexing starting from 0 and all those ones, and also some issues with NumPy. And then that it's a NumPy array, so we have to also specify this I here so that we know that we are out of those multi-band raster. That multi-band raster maybe is the third one that we are currently on, so this I should change to the third and all those ones. If your composite throws an error, you do it this way. Other than that, if it works like this, then you are also good to go. Okay, so that is it also about compositing rasters, or sorry, clipping rasters. We cannot do merge today. The stream is almost 2 hours. Our maximum was supposed to be around 1 hour 30 minutes. So we will end it here and continue tomorrow. But as always, I will leave a minute if there are questions that I have to address on air. Other than that, we close today and anticipate for tomorrow. Okay, so there are no questions. So let me thank you once again for joining today's stream. I hope you enjoyed it as always. So have a great day, all of you who are still in the day, and have a good night, all of you who have to retire to bed. And until next time, it is goodbye.